Hello everyone, welcome to Civil Galaxy. In today's session, we shall see how to analyze a continuous beam with the help of software Staad Pro. So for that, I have considered a problem over here where span AB is having a length of 5 meters and carrying an eccentric concentrated load of 40 kilonewton at a distance of 2 meters from point A, and span BC is having a length of 4 meters and carrying an UDL of intensity 10 kilonewton per meter, and span CD is having a length of 3 meters carrying a central concentrated load of 30 kilonewton. So if we want to analyze this particular continuous beam with the help of software Staad Pro, so first we shall go for software over here. The first thing we can do here is go for configuration, and the base unit should be set for metric here, and the Staad default design codes, this should be set for IS 800, and the concrete design code should be set for IS 456. So just give accept. So then go for new project. If you're analyzing a beam, we will select space. If you're analyzing a frame, we will select plane. So since we are analyzing a beam over here, we will select space, and the length unit should be in terms of meter and the force unit should be in terms of kilonewton. So give next. So add beam, it is selected by default. So go and give it finish. So we are getting an isometric view over here. We don't need this one. So just give close over here and come on this window and just click here. And at the left corner over here, we can see front view. Then go over here. If you come for this beam here, the starting point at A, it is 0. So we'll give the distance 0 over here. And after 0, we are having a distance of 2 meter where a concentrated load of 40 kilonewton is acting. So from here to here, the distance will be 0 plus 2. So give 2 over here. After that one, from 2 we are having a distance of 3 meters, but in Staad Pro we are considering the distance from the initial point over here. So 0 plus 2 plus 3, that will be equal to 5. So we have to press 5 over here. So next, similarly 5 plus 4 will be equal to 9. Then after 9 we are having 1.5. So this will be equal to 10.5. Enter. So after that one again we are having 1.5. So 10.5 plus 1.5 will be equal to 12. So come here and just click on this window over here. Now what we have to do here is we have to go for add beam. Just click on this node and connect the nodes and leave once again here. Just again click the nodes and connect to the another node. So similarly complete the entire beam over here. So then press escape. So this is finished here. So now if you want to see whether the distance whatever we have given as per the problem which we have considered, just go for dimensions over here and click and just give display. So we can see here this is 2 meter, 3 meter, 4 meter, 1.5 and 1.5. The same we have considered here also. So this job is over here. So just close this window over here. Now go for general and go for define. We will define the property. We will consider it as a rectangular section. The depth we shall give it as 0.45 and the width we will give it as 0.23. So go and add over here. Just close. So this has been added over here. So now we have to define this one. So just go for use cursor to define. If you use cursor to assign, we have to go and assign for individual span over here. Since we need for the entire beam over here, just we'll go for assign to view and just give assign, give yes. See here now it is assigned for the entire beam. So this is over here. Just close over here. So we can see here the nodes are not visible whatever we have given. So if you want to get the nodes to be visible, just press shift and K. So we can see here the nodes are again visible. Now we will assign the supports. Go for supports. So since there is no support, first we will go for create support. If you see the beam over here, we are having one fixed beam, one fixed support and 3 roller supports. So here in the first option we are getting fixed. Just go and add over here and again go and create. We are having 3 roller supports. So if we go here for the third option, we are having pinned, but this is the a roller support option. So we know that roller support is capable of taking only one vertical reaction. So just release all the other forces over here and just add. So support 2, that is fixed support. So we'll use cursor to assign because it is having a fixed support only at point A. So we'll go for assign and just assign at point A over here. Then similarly, we'll go for support 3, use cursor to assign, take assign once again after a distance of 5 meters at point B. So after 5 meters at point B, we are having one roller support, and after 4 meters again, we are having a roller support over here, and after 3 meters, sorry, and after 3 meters over here, we are having a distance roller support of after 3 meter distance over here. So here we will assign a roller support. So now the supports are assigned. Just close this one. Next we'll go and give the assign the loads. So we'll go for load case details over here. Go for add. First we will take the dead load and the title we'll give here DL for dead load. Just add here and close. Again we'll go for load case details and we'll add over here. So the second load we'll give it as live load. Take it as the title, we'll give it as LL. So just go and add over here. So in dead load, just go and give add over here. So this is the self weight over here. It is taken automatically. We did not change anything in this one. In the y direction, it is coming in the vertical direction. So it is negative. It is taken automatically. So just go and add this one and close. So we can see here the self weight has been assigned, which is having a question mark. So the self weight is added for the entire beam over here. So we will just click on this one and we'll go assign to view and just assign and give yes over here. See, now the self weight has been added for the entire beam over here. Now we will take the live load, click on the live load here and just give add. So in the live load we will go for member load over here. We are having uniform force. If you see the particular problem over here, we are having a uniformly distributed load of 10 kilonewton per meter. So we will take minus 10 because in Staad Pro we are giving negative because vertically downward force it is coming, we are taking it as negative 10 kilonewton per meter. So just add over here. So we can see here the load has been assigned. So now we have to assign this one for this particular beam over here, which from a span of B to C having a distance of 4 meters. So go here and use cursor to assign, and assign we can just assign over here. Now again we'll go for live load, we'll add. We are having two concentrated load over here, 40 kilonewton and 30 kilonewton. So just go for member load over here. In that one concentrated force we are having two concentrated force, one is minus 40. So just give add over here. Another one we are having minus 30. So go and add over here. So just close. So we can see we are getting two forces over here. So 40 kilonewton is acting at a distance of 2 meters from point A. So this force will go and we'll use cursor to assign, and assign we will at a distance of 2 meters we'll just press over here. See, we can see here this is not coming exactly at a distance of 2 meters. So what we will do over here is we'll go over this point here where we have taken the concentrated load of 40 kilonewton. We will double click on that one and we'll give the distance over here D1 at a distance of 0 meters and change, and we'll close. See, now it has come exactly at a distance of 2 meters. So similarly, the another concentrated force, use cursor to assign, and at a distance of 1.5 meter from point C. So here also we can see it is not exactly at the assigned point. So we'll double click over here and at a distance of 0. So change, close. So now we can see we are having the loads exactly as per the problem over here. So now the loads are not visible here. So to make that visible, we'll go over here. We are having loads, so we'll get here, but the values of the loads are not visible over here. So for that, we'll go for scale over here, and in scales, we'll go for labels. Here we are having an option load value V. So we'll press that one, and we'll just press apply and OK. So now we shall see we are having the values assigned. Here it is -40. Here you can see -40 at a distance of 2 meters. And here we are having 30 kilonewton per meter over a span of 4 meters and 30 kilonewton at a distance of 1.5 meter from point C over here. So now after this one, what we'll do is we have to go here, analyze and print. So we'll give add over here, close. We can see one option has come, perform analysis. Again, we'll go here, define commands, and we'll give again add over here, close, and we'll close this one over here. So if you want to see the loads, again we'll go here, we'll go for loads. So the loads will be visible over here. Now we'll go for analyze, run analysis. We'll give save. So it will perform the analysis. We can see here there is no error. We are having only one warning. We can ignore the warning, but there should not be any kind of error over here. So if we want the output file, we will just click over here and we'll give done. So we'll get something like this. We'll get the total number of degrees, that is 27, and whatever the members we have assigned. But we need not want the output in this way. So what we'll do is we'll go for post processing over here. So we'll give just OK. So now we can see we are having the values over here. Just we will maximize this one. We'll go for loads over here, and then we'll go for beam here. So we can see we are having the bending moment diagram in the y direction. Here if we go, we'll get shear force. We are getting the value of shear force also. So if we go for graphs over here, we can get the shear force and the bending moment. So we'll go for here forces. So since we want the values, what we will do here is we'll go for results, we'll go for view value, and we'll go for beam results over here. We want bending, we want shear, and we want combined displacement. We don't want axial, we don't want combined bending and axial stresses, we don't want. So we'll just take bending and shear and we'll annotate it. So we can see here we are getting the value, and if you want the shear force value, if you just click, we are getting the shear force value also. So this is how we can analyze a continuous beam with the help of software Staad Pro. So similarly, we shall see a few more problems in the next coming classes. Thank you.